Welcome to this explainer. Today, we're diving straight into the invisible geometry of human movement. You know, if you've ever kind of struggled to visualize how our joints actually act as hinges, or how physical therapists analyze a gait, well, you're definitely in the right place. We're going to break down the source material and basically build a blueprint of exactly how the human body moves through space.
Here's our roadmap for today. We'll start with ground zero anatomical position, move into the three cardinal planes, then tackle the axes of movement, and finish up with a really handy exam cheat sheet.
All right, Section 1, Ground Zero, Anatomical Position.
Okay, so before we can start building out our imaginary flat surfaces and hinges, we absolutely have to establish a universal starting point. Think of this as absolute ground zero for the human body. It's the fundamental baseline posture from which all body movements are described across biomechanics and kinesiology. Honestly, if you don't start here, every single clinical assessment you make will be totally backward. It's the geographic anchor for medical professionals worldwide.
There is actually a super strict physical checklist for this. Just picture someone standing perfectly straight according to these rules. Upright, face forward, arms naturally down by their sides, palms rigidly facing you, and feet just slightly apart. That one seemingly awkward detail, the palms facing directly forward, is actually crucial. Without it, we wouldn't be able to accurately map forearm rotation later on.
Moving right along to Section 2, the three cardinal planes.
With the body locked into that anatomical position, let's look at our first imaginary flat surface, the sagittal plane. By definition, it's an imaginary flat surface that divides the body exactly into right and left halves. Just imagine a giant pane of glass dropping straight down the middle of your nose, splitting your entire body perfectly into a left side and a right side. Any movement traveling parallel to this glass, that lives in the sagittal plane.
So what does that actually look like in motion? Well, the sagittal plane is basically your corridor of forward and backward movement. If you're doing a squat, going for a run, knocking out a classic biceps curl, or even pointing your toes, your limbs are moving right parallel to that imaginary piece of glass. It covers flexion, extension, hyperextension, and those specific ankle movements like dorsiflexion and plantar flexion.
To really ground this clinically, visualize a physical therapy patient bending and straightening their knee after an ACL reconstruction. That repetitive, absolutely critical healing process, driving the heel back and straightening the leg out, happens entirely in the sagittal plane. It's literally the foundation of lower limb rehab.
Okay, let's move to our MEX plane and see how this builds. This is the frontal or coronal plane. This time around, the glass slices down sideways, separating your anterior or front chest portion from your posterior, back portion. Imagine you're standing flat between two really narrow walls in a hallway, and you can only move sideways. Side-to-side movement is the absolute star here. Think about doing a set of jumping jacks or reaching straight down your side towards your knee. Your arms and legs are sliding flat against this front-to-back divider. This includes abduction, which is moving away from the center, and adduction, adding back to the center, as well as the lateral flexion of your trunk.
A fantastic clinical example of this is a physical therapist prescribing hip abductor strengthening to correct the lateral pelvic drop you see in Trendelenburg gait. If a patient's hips dip side to side unevenly when they walk, the specialized side leg raises used to fix that weakness occur entirely in the frontal plane.
Our third and final cardinal plane is the transverse, also known as the horizontal or axial plane. This imaginary flat surface divides the body directly into upper and lower halves. It acts exactly like a magician cleanly cutting an assistant in half at the waist, though, hopefully with a lot less mess, entirely separating the top from the bottom.
So the big takeaway here is that any twisting or rotational motion lives purely in this plane. Whether it's a really powerful twisting golf swing, turning your palms up and down, or even simply looking over your shoulder to check a blind spot while driving, your body is moving across that horizontal divider. Internal and external rotation are the undisputed kings of the transverse plane.
If you've ever had to rehab a rotator cuff using a resistance band tied to a doorknob for internal or external rotation, you were doing targeted transverse plane therapy. You were anchoring your arm and purely rotating the joint along that specific horizontal slice.
All right, on to Section 3, the axes of movement.
So we've built our three flat surfaces, right? But to actually bring the body to life mechanically, we really need imaginary hinges. And this perfectly illustrates the core difference between the two concepts. Planes are the imaginary flat environments you move through.
Axes, on the other hand, are the imaginary lines, the actual hinges that you rotate around. Movement fundamentally requires a plane and an axis interacting completely perpendicularly to one another.
Let's look at the first one. Picture a solid steel rod driven from your left hip straight horizontally across to your right hip. This is the frontal or mediolateral axis. Because this pin runs horizontally side to side, it is perfectly perpendicular to the forward and backward sagittal plane. It's just an incredible mechanical design. This exact perpendicular pin allows your leg to safely swing forward and back, powering all of our flexion and extension.
Now take that imaginary pin and drive it straight through your belly button, directly out your back. This is the sagittal, or anteroposterior axis. It runs front to back, making it perfectly perpendicular to the side-to-side frontal plane. By pivoting around this specific rod, your arms and legs are able to safely swing side to side like a pendulum, driving abduction and adduction.
Finally, imagine a long pole dropping straight down through the very top of your head, running all the way out through your feet. This vertical, or longitudinal axis, sits entirely perpendicular to the transverse plane. This vertical pole is the anchor that allows your spine and neck to securely spin around it, giving us all of our internal and external rotation.
I know we've thrown a lot of abstract, invisible geometry your way in just a few minutes. So how do you actually organize and easily lock these perpendicular patterns into your brain right before a high-stakes anatomy or kinesiology exam?
Which brings us to Section 4, the exam cheat sheet.
This is the moment where everything just clicks together into a master system based purely on our source material. This matrix flawlessly maps out the perfect, unbreakable relationship between every plane, its opposing axis, and the resulting movement. Look closely at the crossing pattern here. The sagittal plane pairs with the frontal axis. The frontal plane pairs with the sagittal axis. They are structural opposites that completely rely on one another.
Let's distill that into pure gold. If you memorize this one golden rule, you will literally have the definitive mechanical code of the human body, and you'll never get a biomechanics or goniometry question wrong again. Here it is. Sagittal plane to frontal axis equals flexion and extension. Frontal plane to sagittal axis equals abduction and adduction. Transverse plane to vertical axis equals rotation.
I'll leave you with this final kind of fun challenge. The next time you step outside or even just walk down a hallway, look at someone simply walking by. Don't just see a person walking. See if you can actually identify that beautiful, invisible geometry, the sagittal corridors and the frontal hinges making their every single stride possible. Thanks for learning with me on this explainer. Keep visualizing those mechanics and